This is the typical structure of indole. Now, what makes indole reactive is this lone pair of electrons on the nitrogen atom. And that electron is very, very important in indole reactivity. Now, carbon 3 electrophilic substitution, this position 3, is the most fertile ground with regard to indole reactivity. So whenever indole comes across an electrophile, remember electrophile is electron deficient species looking for an electron rich center to attack. So because of the localization, this lone pair of electrons is delocalized here, and that makes this region very electron rich, and that can readily be prone to reaction by an electrophile. So when an electrophile attack, it forms an intermediate. The positive charge is imparted on this nitrogen because of the shift away of the electrons. So the electrophile is now forming a bond, partial bond, like that. Now, to stabilize this molecule, this part is electron deficient. So this lone pair of electrons is delocalized back. To neutralize that positive charge, and that's why you have this here. So that will result in the breaking of the carbon H bond here. So this electron is coming down here again. So the electrophile is now added. So most of the reactions of indole is on carbon 3. So we can see the electrophile has been attached to the indole family. Now, looking at the overall reactions, we can see the intermediate, that this carbon 3 is prone to electrophilic substitution. Electrophilic substitution because the hydrogen is released as H plus at this stage in order to have the electrophile being reactive. Example of this is reaction of indole with bromine. You can illustrate it. The bromine is an electrophile. So if you have a reaction of indole with bromine, you can react this indole with Br. So this part will be an electrophile that can react. So at the end of the day, you are going to have bromine substitution at carbon 3 position. The bromine will be substituted at carbon 3 position. So you have bromine being substituted at carbon 3 position. So that's the typical reaction of indole group. Substitution reactions at position 3.